And we are online. Okay. So today we are going to talk about aircraft performance. In this video specifically, we're going to talk about density, altitude, and how humidity, pressure, and temperature will affect your aircraft performance. So let's dive right into it. The structure of the atmosphere. So just a quick recap. The atmosphere, that's basically a blanket of air that envelopes the Earth, and it's just a mixture of gases. It's made out of 78% nitrogen, 21% oxygen, and 1% other gases, such as argon or helium. Next, atmospheric pressure. That's basically the pressure of the atmosphere. Why do we care about it? Because it affects our airplane's performance and our instruments too. Those instruments include the altimeter, the airspeed indicator, the vertical speed indicator, and the manifold pressure gauge. Okay, so as pilots, we really care about the density of the air. Density meaning within a given volume, how much air is in that. Why do we care about the density? That's because the density affects our airplane's performance. So, as the air becomes less dense, it reduces the airplane's performance. It affects mainly three things. So, it affects the power. So, because the engine takes in less air, it reduces the thrust. Less density equals less thrust, and that is because the propeller is less efficient in thin air. Less density means less lift, and that is because the thin air exerts less force on the airfoils. Okay? So now there are a couple of things I want to point out and a couple of things you need to jot down in your notes because this will become pure memory for you for later in the test. So the International Civil Aviation Organization, we call it the ICAO. They created a worldwide standard, right here, a worldwide standard. And this standard is to describe what's called a set of perfect conditions. And that standard is defined as if this was a standard atmosphere, then the temperature would be 15 degrees Celsius or 59 degrees Fahrenheit. You can see I underlined the 15 degrees Celsius in blue because that's what the FAA wants you to remember. And a standard atmosphere also has a surface pressure of 29.92 inches of mercury or 1013.2 millibars. Again, you can see that I highlighted or underlined the 29.92 inches of mercury with blue because that is what the FAA wants you to memorize. So write down in your notes these two numbers and then commit that to your memory. Along with the standard atmosphere, there is also a thing called a standard temperature lapse rate. What that means is as you increase in altitude, you also decrease in temperature. So you decrease 3.5 degrees Fahrenheit in temperature for every 1,000 feet you rise. But I underlined this, 2 degrees Celsius, because that is what the FAA wants you to remember. So also write that in your notes per 1,000 feet. Once you reach up to 36,000 feet, however, the temperature stops decreasing. The temperature stays constant actually up to 80,000 feet. And let's keep on continuing. Oh, so this is just a chart just describing what I just said. As you increase in altitude, the pressure decreases and the temperature decreases up to, again, what did it say? 36,000 feet. Well, this table doesn't even go up to 36,000 feet. Okay, pressure altitude. You might want to write this down in your notes, but this book defines pressure altitude as the height above the standard datum plane. What does that mean, standard datum plane? The standard datum plane is basically an imaginary plane that the scientists made up. It's imaginary. Why did they do that? It's basically just a reference line. They needed a reference line. And the pressure altitude is how I would describe if the pressure is 29.92 inches of mercury, that's what the altitude would be. That's basically what it is. So how do you find pressure altitude? Well, if you set your altimeter to 29.92 inches of mercury and you read it off, that would be your pressure altitude. And let me show you real quick. I have an altimeter here, right here. This is how you set it. You actually twist this knob, and then when you twist this knob, these numbers move. And do you see this pointer thing? It's already set to 29.92. And then you would read this off. As you can see, this reads 100, 10,000, 1,000. So this would read 4,000. So the pressure altitude in this case, because it's already set to 29.92, is 4,000. Let's go back. Why do we care about that? Well, we will need it later because it helps us find our density altitude. There's 3 ways to figure out what the pressure altitude is. It's the first way, which I told you about, using your altimeter. Or you could use this chart. This book says apply a correction factor, use the chart. I actually don't use the chart, I do math. And I'll show you this math later when we do practice problems and we actually need to compute this. But if you are willing to learn this chart, you can look it up in the book. It's right here. And again, it says use a flight computer. So those are the 3 methods. I don't use a flight computer. I do the math. I will teach you the math later. Or I do this, get in the airplane, set the altimeter. But sometimes when you are in the FBO doing flight planning, you don't want to walk all the way to the hangar and get in the airplane just to read a number. So it's just easier to do the math for me, actually. Okay, what is density altitude? Okay, the book has the definition of density altitude. Is pressure altitude corrected for non-standard temperature? That is the definition according to the book. How I like to think about it is the density altitude is the altitude that the airplane thinks it's at. What does that mean? If you're sitting in the airplane on the ground and your field elevation is 1,000 feet, you would think the airplane would perform as if you were 1,000 feet off the ground. What does that mean? You would calculate the takeoffs and landings based on that number. But that is only in a perfect world, because temperature affects your density and that affects your density altitude. So I'll give you a scenario. if you are on the ground and the field elevation reads 1,000 feet and the density altitude actually is 3,000 feet, then the airplane will think it's at 3,000 feet. What does that mean? That means if you were to go to an airport that had a field elevation of 3,000 feet, you would have a longer ground roll, and you would it would take longer to take off, and you would need longer runways to land. So when I say the density altitude is the altitude the airplane thinks it's at, it means the airplane will perform as if it was at 3,000 feet, even if you are actually just 1,000 feet field elevation. So when you do your calculations to figure out your ground roll, how much runway you need to take off and land, you need to use your density altitude, not your field elevation. So let's recap. Why do we care about pressure altitude? Because pressure altitude will give us our density altitude. Why do we care about density altitude? Because density altitude will tell us how our airplane will perform, how much runway we need to land and take off, how much the airplane will climb. So that is why we care about these things. Okay, let us, I suppose I would need to teach you how to calculate density altitude now. And I will, we'll get to that. We will do practice questions. Okay, let's see. The effects on density. Okay. Okay. As air density decreases, aircraft performance decreases. A decrease in air density means a high Let me read that again. As air density decreases, you have a higher density altitude. Let me give you a way to think about this. As you climb up in the air, you have a higher altitude. That's why you have a higher density altitude. But as you climb up in the air, your air density decreases. So I'll give you a while to think about that. Aircraft performance decreases. A decrease in air density means a higher density altitude. An increase in air density means a lower density altitude. You probably should write that down in your notes. Okay, we're going to go over effects on density. So how does temperature affect density? Higher temperature means lower density. Lower density means higher density altitude. Higher density altitude means lower performance. So this is a decrease in performance. I'm actually just going to write everything down for you because I feel like you need it. So I'm going to put an arrow, means, okay, increase in temperature. We'll put T as in temperature. If you increase your temperature, you decrease performance. Okay. Maybe I should just make you a table. Wouldn't that be easier? I'm gonna write in this space right here. Okay. Maybe I'll write in red. An increase in temp means you have an decrease in density. A decrease in density means you have an increase in density altitude. An increase in density altitude means you have a decrease in performance. Performance. And then I'll draw a sad face. Okay. Means. So that means hot temperature is bad. And cold equals good. There. Hot, bad, cold, good. If you can't remember anything, just remember that. Okay, so how does humidity affect density? Let me draw that again. I'm going to draw in the corner. I'm going to draw a corner over here. An increase in humidity means a decrease in density. A decrease in density means an increase in density altitude. An increase in density altitude means a decrease in performance. What does that mean? Sad face. Humidity is bad. So I will write humid, bad. Dry, good. And I'm just going to give you some time to write that in your notes. Why does humidity cause a decrease in density? The reason for that is because water vapor is lighter than dry air. So if you imagine in your head, you know what, you don't have to imagine, I'll draw it for you. Okay, this is a box of air. The box of air has air in it. What a surprise. Those dots are just air molecules, right? Let's say the box of air is now humid. Oops, water's in there. And let's say these red dots is water. So now, does the box of air have less air or more air? The answer is less air. And if it has less air, is it more dense or less dense? It's less dense. Less dense equals bad. That's why humidity causes the air to become less dense. That's my way of trying to explain it, but the scientific way is written in the book, and I shall highlight it so you can read it. See right here, water vapor is lighter than air. Consequently, moist air is lighter than dry air. Therefore, as water content of the air increases, the air becomes less dense, increasing density altitude and decreasing performance. That is for the scientific mind. If you liked that explanation more than the one that I gave you with my drawing on the side. Okay, so we are going to continue. Okay. Man, all this stuff is so good. I would love to go over it, but actually, if you looked at the test, they never really ask about any of this, even though it's like really good stuff to know. I think I will make like a separate video, like just for us to learn about it, not because we need it for the test, but we will just stop right here. And we're just gonna go do some practice questions because that's all we needed. We just needed that information to actually learn how to, oops. Just give it a while. Okay, so we're gonna go over all this, excuse me, all this practice questions together. What effect does high density altitude as compared to low density altitude have on propeller efficiency and why? Okay. So, man, my voice is gone. Hello. High density altitude. Is that bad or is that good? So as you go higher in altitude, does the air become less dense or more dense? It becomes less dense, and less dense means a decrease in performance. A decrease in performance is efficiency decreases. Okay, so we're going to choose the answer with efficiency is reduced. So now we're going to look at this. One says efficiency is reduced, or two of them say efficiency is reduced. So now we have to choose between these two, between A and B, or B and C. Sorry, I can't speak. It says efficiency is reduced because propeller exerts less force at high density altitudes than at low density altitudes. That's one option. Second option, efficiency is reduced due to the increased force of the propeller in thinner air. If you had thinner air, would your force increase? I don't think so. The answer is B. Oh, by the way, you can just like pause the video when I read out the question, and then you can just answer it yourself. And then if you don't need me to explain it, you can just skip ahead in the video to when I press the answer. That way you don't, have to listen to me talk. Or if you don't know the answer, you could just listen to me explain everything. That's the most efficient way to use to study. Just pause the video, answer the question yourself, and then skip ahead to get the answer. And if you get it wrong, then go back and then see how I answered it. That way you can just skip all the boring parts of hearing me talk. Okay. If the outside air temperature at a given altitude is warmer than standard, the density altitude is. So what did we say again? We said, if the outside air temperature at a given altitude is warmer than standard. Oh. So we said, how does temperature affect density altitude? We said, if you increase the temperature, then you lower the density. If you do that, then you increase your density altitude. So we have to find the answer that says increase. Yes, there it is. Which combination of atmospheric conditions will reduce aircraft takeoff and climb performance? It's asking which one will reduce performance, okay? Okay, let's start with this. Which temperature reduces performance? We said high temperature. Okay, now it's asking about humidity. Does humidity decrease or increase performance? Humidity decreases performance, so we're going to go with this one. And is high density altitude good or bad? It's bad. So the answer would be C. What effect does high density altitude have on aircraft performance? We already know this one. It will decrease. So we have to choose the answer that decreases. Okay, this is when I teach you how to use graphs and do some math. Refer to figure 8. What is the effect of a temperature increase from 25 to 50 on density altitude if the pressure altitude remains at 5,000 feet? So we're going to open this. Oops. And I want to save this. I'm going to save this because I want to draw on it. Okay. First, let's memorize the question. It says 25 to 50 degrees Fahrenheit, and it's asking for density altitude, and it says the pressure is 5,000 feet. I'm going to write that down in the corner here. So it said 20, was that 20? 25, see, look at me, I can't even remember anything. 25 degrees, and it changes to 50 degrees, and it said our pressure altitude equals 5,000 square feet. Feet. Not square feet, just feet. Is that it? Maybe they'll just split the screen. Ah. Look, I'm so smart. I split the screen. Wow. What does this do? Is this like a ruler? Okay. Sorry guys. Let's look at this. I don't know why I had to write all of that stuff here when I have the question right here. Oh, whatever. I'm just an idiot. All right. So this is a density altitude chart. On the bottom, it says outside temperature. On the side, it says approximate density altitude, thousands of feet. This, we don't have to worry about this right now. I'll talk about it later when we need it. I don't really use it, but you might use it. And then we have this red line that says standard temperature, and we have lines that says thousands, 2,000 sea level, and then it says pressure altitude feet here. How do we do this? We are looking for the density altitude. So what we do is we start with 25 degrees Fahrenheit. So we're going to zoom in here. We're going to find 25 degrees Fahrenheit. You notice here there's like two sets that says Celsius and Fahrenheit is on the bottom. So we're going to use Fahrenheit because they gave us Fahrenheit. And you have to pay attention because they try to trick you. Sometimes they say Celsius. But you are smarter than that. So you use the bottom one that says Fahrenheit. And we go to where it says 25. So 25 would be this line. And I actually might need this ruler. This ruler might come in handy. So I'm going to put this ruler. And I'm going to put this ruler here on this 25 line. And then, do you see these lines that go here up to here? That is actually your pressure altitude. So this says pressure altitude is 5,000 feet. So you go up to 5,000 feet, and then you see where this line crosses here. that is where you draw the line. Okay, so that blue line I just drew from 25 all the way up to this 5,000 feet line. And then you take your ruler. This is pretty cool, guys. I didn't know I could do this. And then you make a straight line using your ruler to this edge where it says approximate density altitude. And you notice it says thousands of feet, so it reads as in 1,000, 2,000, 3,000, and this would be 4,000. And then you zoom in to see what it says. So if these are in thousands of feet, then every little box would be 100. So this would be 3,000, and then you count 100, 200, 300, 400, 500, 600, 700, 800, and then your density altitude would be 3,800, okay? But it said the temperature changed to 50 degrees. So now you have to find 50 degrees. Remember, it's Fahrenheit, so it's the bottom one. It's 50 degrees here. You take your ruler, line it up to 50. Okay, then you take your pen and then you draw up that line all the way to 5,000 because remember the pressure altitude is 5,000, so 5,000 is this line right here. And then you take your ruler, you line it up there, and then there. And you read what that reads. So you zoom in, and then it would be 5,500. And then what you do is you take these two numbers and then you subtract them. So it would be 5,500 minus 3,800. And because I am not very smart, I have to take out my calculator. Just give me a second while I calculate that. Maybe you smart people can do it in your head. Okay, so I got 1,700 feet. And then we look at our answers. So oftentimes, you won't find the exact answer among the answers you have here. And the reason why is because look at this chart. Look how tiny those tick lines are. How are you supposed to get it exact? You can't. Not really. So what you do is you just pick the one that's closest. So I got 1,700, and this seems like a pretty good close number to what I got. And hey, look at that! My answer is correct. So, pro tip, when you actually take the test, a lot of times when you do the calculations, the answer you get would not be exactly the same. So what do? Just pick the one that is closest. Okay? Good job, everybody. Next. Okay, everyone, we are back online. We had some technical difficulties, but now we are good. Our next question is, determine the pressure altitude with an indicated altitude of 1,380 feet MSL with an altimeter setting of 28.22 at standard temperature. So if you remember, we we were going to go over this chart. This is the chart that we are going to use to answer this question. So on this side, it shows the altimeter setting. On the other side, it shows the pressure-altitude conversion factor. So that's what we need to find the pressure-altitude. So what you do is you take the altimeter setting, it says 28.22, and then you go to this chart and you try to find that on this chart. But if you notice, they don't have a 28.22, they only have a 28.2. So what do? We know the answer is somewhere in between these two numbers. Instead, we will do this thing called interpolation. What does that mean? It means we are going to do some math. Okay, we're going to do some math. First, what we do is we find the difference between these two numbers. So we subtract them. So I'm going to take out my calculator. Take out your calculator, or unless you can do this in your head, do 1630 minus 1533. That number is 97. 97, okay? You're going to take this 97 and you're going to divide that by 10. So that's 9.7. Okay? You're going to take this 9.7 and you're going to multiply that by 2. Do you know why? Well, you don't really need to know why. You just need to know it works. But I can explain it to you. Hold on. So if you did that, it would be 19.4. I'll show you the answer first, and then I will explain the math. Some math people might know, and some people might not even care about the math. So you take this 19.4. Just a reminder of what we did. We found the difference between these two numbers. We divided this number by 10, and then we multiplied this number by 2, and then we got this number. What we do with this number is we take this number, 1630, and we subtract it by this, minus 19.4 equals 1630 minus 19.4, 1610.6. Okay, this is the conversion factor right here. Why do we have to do that? If you don't really care, you can skip ahead. I'm just going to give you a very nerdy math explanation. Here goes my very nerdy math explanation. What is interpolation? We know that 28.2 equals 1630. We know that 28.3 equals 1533. And we want to find what 28.2 equals. And we know that 28.2 falls between these two numbers. So if you were to imagine, if we were to think about this, why did I break or divide this by 10? Okay. I made you find the difference between this 97, right? 97. So why the number 10? Because between 28.2 and 28.3, there are 10 digits, if you will. Let's see, 28.21, 28.23, 28.24, and it goes 1, 2, 3, 4, 5, 6, 7, 8 until 10, right? Again, I remind you, if you don't want to listen to this explanation, it has nothing to do with aviation, it's just nerdy math. Go ahead and skip, okay? So why did I take this number and divide that by 10? Because between this number and this number, there are 10 digits. So I divided it by 10. So we divided it by 10, we got 9.7. So what does that mean? That means, I just realized I skipped the most important number. There. That means we divided it by 10, so each number has 19.7 portions, right? But so like 1/10 would be 9.7, but we don't want to know what that 1/10 is, because we want to know what 0.22 is. So that's actually 2/10. So that's why I multiplied by 2, which is 19.4. So then what do you do with this 19.4? We have to add it, or subtract it from 1630. And why did I subtract instead of add? Because you can see as you go this way, the numbers decrease. So it's subtract, it's not add. And that is my very nerdy math explanation. It might not be a very good explanation because I'm not a math teacher. But if you're wondering what you should do if you're on a test and you can't remember this math, here is my go-to solution. I hope you would at least remember this instead of that entire explanation. If you're, okay, to interpolate, just find the difference. Find the difference, divide that by 10, and then take the last number, which is 2, get that, and either add or subtract depending on if it's numbers going down or up. And I hope you remember at least that. If it's hard for you to remember, the best way to do that is to practice questions over and over again, and you have no choice but to remember because you just did it so much. That's the only advice I can give you. Okay. Sorry for that very long math explanation that has nothing to do with aviation. We have this number. This is called the conversion factor. We're not even done with this question yet. Wow, it took us so long. What do we do with this number? We take this number and we add it. We add it to this number. Okay? We add it. So we take this number, we add, that's a plus sign, 1380. What do we get? Calculators, anybody, give us the answer. 1610 plus 1380. We get 29906. Okay? we don't like decimals, so we're gonna round up. So we got 2991. Is this the answer? Well, let's look. Oh, it is the answer. And somebody already pressed that. That was me accidentally. Oops. Very long math nerdy explanation. The best way to do this to prepare this for the test is just do it over and over again so you can't forget. So that's that. Let's go next. Determine the density altitude for these conditions. They give us the altimeter setting, they give us the runway temperature, and they give us the airport elevation. And they want density altitude. Okay. So how do you find the density altitude using these? So you need what you need to find the density altitude is you need the outside air temperature and you need the pressure altitude. So we need to figure out what the pressure altitude is, and we're gonna use the altimeter settings to find out what the pressure altitude is. I'm gonna do some quick math to figure that out. So I did some quick math. I found out the pressure altitude is 5,920. I can show you what I did. You can use the chart the same way that I taught you how to use the chart. But I just did this quick trick without using the chart because it was, the chart, if you remember the last question, it took that long. Okay, what I did. I did 29.92, and then I did 29.92, that's standard atmospheric pressure, if you remembered, because I taught you, and I subtracted that, 9.92 minus 29.25, and if you did that, that would be 670, okay? If you multiplied this by 1,000, you would get 670. And you take that number and you add it to your airport elevation. So that would be 5250. And then you would get 5920. Do you see this number here? This is the conversion factor. So how do I know if the math I just did was right? I take this and let's just look. If we were to use this chart, if we were to find 29.25, so we find 29.2, and then of course 25 isn't here. Our number that I just got using the math that I just did, is 270. It lies between that, so it's close enough. Close enough, okay? Close enough. So this number that I just got looks pretty plausible. Looks pretty good. Okay. So same way as we did the previous questions. We take the runway temperature. Remember, it's Fahrenheit, so we go down and we see Fahrenheit. I'm gonna zoom in. Okay guys, I'll zoom in. So I'm gonna zoom in a lot. I found 81. I'm gonna put my I'm gonna put my ruler at 81 here. 81 to the best that I can. And I am going to take my pen, draw the line from here all the way to the pressure altitude, which, what was it that we said? 5,000. So do you see how the line goes to 5,000? In the middle between this line and that line would be 5,500. And we would guesstimate that 5,900 would be somewhere around here. And you can see why the numbers that we come up with will not really match the numbers the answers show, is because everything is just guesstimation. I don't really know where 5,920 is. I can only guess. But we draw this line right there, just like how we did in that previous question. Zoom in and figure that looks about like 8,500 feet. What do you guys think? Is that an answer here? Yes. And voila, it's right, guys. We did it right. Again, quick and dirty method on how to get your pressure altitude without having to use that very hard to use chart. You take the standard. Okay, this is a number you have to memorize for the rest of your life till the day you die. Then you take the number that they give you, the 29.25, and then you multiply that by 1,000. Finally, you get your conversion factor. Then you add that to your airport elevation. That's my quick and dirty method on how to do that, because I do not like to use this chart. As you can see from last time's question, it just took a while. It took a while to use this chart, right? Okay, let's go next. Oh, we're doing it again. Pressure altitude. So they're asking for pressure altitude. You know what, guys? Do you want to use the chart? Go ahead and use the chart. If you forgot how to use it, you can go back to that question. I taught you how to use it. But I'm not going to use the chart, guys. I'm going to do math. How do you find pressure altitude? Same thing like I taught you. So 29.92. That is the standard. And then we write down the number that they gave us, 29.96. We subtract that. Okay, calculators out, everybody. Calculators out. 29.92 minus 29.96. That gives us negative 0.04. You multiply that by 1,000. What does that give you? Okay, I got negative 40. So you do negative 40 plus 3,563 feet. Where did I get that number? It's right here, guys. Right here. The question gives you all the numbers. What do you get? What's the answer, everybody? 3,563 equals 3,563 5, 2, 3. Okay? Okay. Before we do anything, let's check our work using the chart. You know, like what if our math is different from the chart? This is the conversion factor, -40. Let's go to the chart. Let's find this number, 29.96 on the chart, and let's see if our conversion factor is close. 29.9, 29 point. Okay. Okay. So 29.92 is 0. And 30 is -73. So our number that we came up with is -40, which is between these two numbers, and 29.96 is between these two numbers. So does it make sense? Yes, it makes sense. Let's see if we're right though, okay? Let's see if we're right. Let's take this, 35, 23. And the closest number I see is this. Let's cross our fingers and hope it's right. And it is right, everybody. So this is proof that you can do math if you think it's easier than trying to figure out the numbers between these two, because that's kind of hard. Or you can do any method that you would like, as long as it gives you the right answer. Okay. What is the effect of a temperature increase from 35 to 50 on density altitude if the pressure altitude remains at 3,000 feet MSL? Okay, let's do this again. Okay, so we take our ruler. It's nice to have a ruler. I'm gonna zoom in. I'm gonna zoom in right there. Take our ruler. We're gonna go to 35 feet with our ruler. And then we are going to draw a line from, did I say 35 feet? I meant 35 degrees. So we're gonna draw a line, and they said the pressure altitude is at 3,000. So I'm gonna draw the line up into this brown line. This brown line, as you can tell, is 3,000 from this brown line right here. I'm gonna switch my ruler, and I'm going to draw a line to there. Okay, and what does that say? Okay, this is 1,000. That says 1,900. 1,900. Okay. Let's try that again. Okay, so that's our first one, and then it says the temperature changes to 50. So take my ruler and put it on 50. Now draw your line up to 30. I mean 3,000. 3,000's right here, everybody. Okay. Switch your ruler. Right there. And then draw the other line. Okay. And zoom in so we can actually read that. What is that? Does that look like 2,900 to me? Okay. So the difference between that is 1,000 feet. 1,000 feet. Okay, so zoom out. Did the density altitude, did it increase or decrease? And I would say it increased. It increased from 1,900 to 2,900. So now we have to choose between these two numbers, and I think it's this. Yes, we got it right. Good job, everybody. Let's go next. Determine the pressure altitude at an airport that is 1386 feet MSL with an altimeter setting of 29.97. Okay guys, let's just do some math. I don't feel like using that chart, but if you would like to use that chart, that is up to you. We will use the chart just to double check our answers. Okay, how do you do this? If you remember, you start with the standard, and everybody must remember what the standard is. It is 29.92. Then you take the setting that they give you, 29.97, subtract. Take your calculators out, 29.92. You know, one of these days I'm going to learn how to do mental math so I don't have to take my calculator out, because I feel like third graders are smarter than me now. Let's see. Remember, we have to multiply by 1,000, and this is our conversion factor. How do we double check our conversion factor? We're gonna use the chart. Dun dun dun. Oh, if you see, I still have this from our last question. Our last question was 96, but now they said it was 97. How very creative of them to pick a number that's just one more than the last question. But we came up with the answer -50. Does that make sense? Does -50 lie between 0 and -73? I think it makes a lot of sense. That's how we use this chart to double check. So we go to our conversion factor and we just add that to the altitude that they gave us, which is 1386 feet. And then you do the math. You do the math. 1386. It's 1336 is what I got. And of course, we look at the answer and none of them match what we calculated. So what do? Just pick the one that's the closest. There. Perfect. Congratulations, everyone. You're smarter than a third grader. Let's go next. Oh, this question is a lot like the previous question. It says, determine the density altitude for these conditions. They give us an altimeter setting, the runway temperature, the airport elevation. Okay, so do you remember how to find the density altitude? If you want to find the density altitude, you need two things: the temperature and the pressure altitude. They don't give us the pressure altitude, they give us altimeter setting. What does that mean? We have to figure it out ourselves. More math for us, everybody. Good, the more you do this, the more you remember. And I'm not even going to try to explain it anymore to you. I explained it to you last time, so I feel like you should already know why I'm subtracting the standard by the altimeter setting that they gave us. And by this time, you should already guess that I'm going to multiply it by 1,000. I got -430. Okay, so I'm going to take this number. This is the conversion factor. I'm going to double check on this chart that we did this right. So we're going to find 30.35. 30.35 should be here. 30.35. Okay, so our number that we got was, what was it again? -430. -430. Does -430 lie between these two numbers? And it does, so that makes sense. So we double checked our work and it looks good, and then we just add that to our airport elevation, and then we get we get 3464. But we're not done. That is not the answer. That was the pressure altitude. So we needed that to find out another answer. Okay, do you remember how to do this? If you find the temperature, it's 25. You like, hold on. You just put your ruler, you'll find 25. 25, by the way, lies between 20 and 30, if you didn't know that. And then you draw your line up till you hit 3,464. How do you know where 3,464 is? Because I sure as hell don't know. I eyeball it. So like, I think this is 3,500. So if this is 3,500, if I just go like maybe a little bit lower, like if I go, I probably have to erase that. Like maybe that is 3,464. What do you think, guys? Do you think that is 3,464? Who knows? Okay. So then I turn the ruler. I draw my line, and let's see what we got. I think so. We have to. If this is 1,000, just count like 100, 200 until this looks like 1,900. Oh, if we look at our options, the closest thing is 200. And why are we like 100 off? It's because I don't know where 3,464 is on that chart. Sorry guys, my fault. But let's see if we're kind of close. We are close. I was only 100 off, everybody. I just don't have enough skills to figure out where 3,464 is. But who cares? We got the right answer. Let's just go next. Okay, don't be tired. We have 4 more questions remaining. Don't get tired, guys. This feels like this will go on forever. It won't. There's light at the end of the tunnel. Okay. What is the effect of a temperature decrease from a pressure altitude increase and a pressure altitude increase on the density altitude from 90 degrees Fahrenheit and 1,250 feet pressure altitude to 55 degrees Fahrenheit and 1,750 feet pressure altitude? Okay. We just do it again. Okay, we start with 90 degrees. 90 degrees, that's pretty hot. Use your ruler, line it up to 90 degrees. Okay. And then you draw the line up to 1,250. So that right there is 1,000 feet. I don't know where 1,250 is, but it's okay. If this is 1,500, I feel like 1,200 would be like right there, probably. You just have to do your best, everybody. Do your best. And then you draw your line. Oh, that's not a very good line. You draw your line, and you find out the answer. So that would be 3,600 is what I'm seeing. 3,600. And then we go next. It dropped to 55 degrees. So take our ruler. We find 55. Well, 55 is between 50 and 60. Okay. You draw your line up to 1,750. So that's 1,000. That's probably 1,500. 1,750 is probably over there. I don't know, I'm just guessing. You just have to guess on your test. That's how you will succeed, by guessing on your test. Then you use your pen to draw. Zoom in. What does that say? I think that says 1900. Okay, and then you subtract 3,600 minus 1900. 3,600 minus 1900. I got 1,700. Okay. Okay, so did it increase or did it decrease? What do you think? This is the number we started off with. We ended up with this number, so that is a decrease. And this is, look, we got the right answer. And we were actually pretty spot on, despite me having to guess like where 1,250 is over here. Our answer was exactly the same as the answers they gave us. I think we are doing pretty good. Okay, what effect, if any, does high humidity have on aircraft performance? Okay, I know it's been a while since I talked about humidity, but I really hope you didn't forget my lesson. I told you. But I'm not going to go back to our notes. I'm just going to tell you. But you better remember this. It decreases performance. It decreases performance. We talked about this at the beginning, but a lot of time has passed since then. I just hope you didn't forget that. What are the standard temperature and pressure values for sea level? Okay, everybody, we've been talking about 29.92 for the past couple of questions. That is something you are not allowed to forget. But they gave us there's two of them, 29.92. So the question is it inches of mercury or is it millibars? It's inches of mercury, guys. And it is 15 degrees Celsius. I want to point out that they try to trick you here because look, 59 degrees Fahrenheit is right. It is right. It is the same exact as 15 degrees Celsius. These two are right numbers. And they put 29.92, which is also the right number. But the problem is this. Millibars? No, that is not correct. It's inches of mercury, guys. If you decided to remember millibars, I think it was like 1,013 millibars. Even I don't remember that either. But we're done with this. We're done, everyone. Oh, okay. Congrats, we're done. And I'll see you in the next video and take a brain break because I think you deserve one. See you next time.